Hello, this is Mike Lively, and we're in Chapter 1 of Professional Papervision, and we're in the section Building a 3D Flash 9 Engine in 18 lines of code, and basically we're going to build a perspective scaling engine here. Let's go ahead and talk a little bit about perspective scaling, what it means, and how it's derived. And all this comes from the Greek philosopher Thales, believe it or not. He was the first one to propose similar triangles, and basically from all of this comes the equation focal length divided by focal length plus z. Let's explain this equation just a little bit. And basically imagine there's a kind of blender monkey I have right here in this figure, and he's looking at a window. And the distance from his eye to the window is the focal length. And outside the window he sees a little nut, and the distance from that nut to the window, which we're going to call our projection plane, is the z-axis. Now just imagine that you're standing in a cabin in the woods, and you're so far from the window looking outside, and so your distance from your eyeball to that window is the focal length. And a bird flies by the window, and the distance from that bird to the window is the z-axis. And so you're looking at that window, and as the bird gets closer, it gets larger, and as it flies away, it gets smaller. And all of that is based upon this equation here, derived by Thales. Now let's just say a little bit about Greek philosophers, because a lot of things came from the Greeks, and we're going to derive this equation right now. And I have a little clip to play for you, so let's go for it.
Every morning my dad would lecture us on the history of our people, the greatest civilization, the Greeks.
Okay, now name three things the Greeks did first.
Astronomy, philosophy, and democracy.
Bravo, very good. Now, give me a word. Any word, and I show you how the root of that word is Greek. Okay? How about arachnophobia? Arachno, that comes from the Greek word for spider, and phobia is mean fear. So fear of spider, there you go.
So this clip comes from My Big Fat Greek Wedding. It's a comical movie, and it's meant to be a little bit funny here, but in reality, so many ideas did come from the Greeks, especially in geometry. And here's a bust of Thales, who derived the idea of similar triangles. He was considered to be the teacher of Pythagoras, and from Pythagoras' theorem comes all of trigonometry. So just gotta tell you, the Greeks really contribute tremendously to science, and that science and mathematics that they developed are still alive and being used today. So let's go back and actually show you his idea of similar triangles. Here it is right here. We're actually going to derive the theorem of perspective scaling from similar triangles. Let me explain this diagram real quick. You actually have two triangles. You have a small triangle right here, okay? And it just extends, and you can think of it as a large triangle right here. And there's a very important rule that happens when you have similar triangles like this. And there's a very important relationship that occurs when you have similar triangles. Basically, this distance right here, in ratio to this distance, is going to be the same or equal to the ratio of this distance to this distance. Okay? Let's show you those equations. So referring back to our diagram, the ratio of small h to FL is equal to the ratio of large h divided by FL plus Z. Wow, that was really simple. And all you have to do now is cross multiply. So if you cross multiply these two terms right here, this by that and this by that, you get little h over large H is equal to focal length divided by the focal length plus Z. And that is the scaling equation that you're going to use to create a Z perspective in Flash. Now if you do a plot of this equation, there's a number of interesting things we need to point out. When Z is equal to 0, right here, your image scale is 1. That's when you're right on the point of the plane of projection. When Z is equal to ZL, that's when your image size is 1/2. As Z approaches the negative of the focal length, your scale approaches infinity. It's like it flips over in your eye, and there's an inversion. And as Z approaches infinity, you're on the other side, your image, in a sense, asymptotically goes to 0. So we're going to show you this scale real quick, but just to point out, I'm actually using the term vanishing point a little bit loosely here. we typically think of vanishing point as something like this. So if you're an artist, you're used to thinking as vanishing points as points to where an image basically converges, and there's where all the lines in the sense of the image converge. So we can actually draw lines along here, and you can say, well, the vanishing point is there. And so I'm using this term fairly loosely, and I'm just saying it's where rays converge. And you actually could think of vanishing point as focal point the way we're using it, but just think of it like this. It's where rays converge, and there's two of them, one at the eyeball and one at infinity. And if you keep that in mind, and you'll let me get away with this, it essentially makes things fairly easy in our derivation. So let's go to the next part. So you can see these 4 points right here on a graph. So let's take a look at the graph real quick. And basically we have these 4 points illustrated here. As you go to infinity, you see that and since you have a vanishing point here where your scale goes to 0. Of course, your rays also do converge at the 0 point here on the axis, and actually flip over, you get an inversion here. So there's your inversion right there. Everything becomes negative at z equals minus FL. And then basically at z equals 0, you have the scale of 1, and at z equals FL, you have the scale of 1/2. So those are the 4 points that were made previously. And let's move on and show you how this is used to create the z perspective using code. So now that I've convinced you of the scaling equation, it's really simple to, in a sense, create a z perspective, z projection in code. And here's the simple code right here. The first equation is your scale equation. That gives you z. The next two equations pretty much work with the position. So you scale the x, and that changes the position of where your object is. And the last equation changes the scale of your object so that when you're going back, it gets smaller, and you're going forward, it gets larger. Now, believe it or not, all of this is incorporated directly into Papervision in the camera class. Let's take a look at that code. So let me illustrate how this is actually used in Papervision. Here's a code snippet taken from one of Papervision's classes, and it's the perspective scaling in Papervision. So if we come along here and just take a look at this code snippet right here, we can see they're using a perspective, which is our scale, and it's the focal length by what they call focus, or it's focal length as well, plus a z parameter. Then the screen position x and y are determined by the x and y times that perspective or scaling parameter. So these ideas, so simply derived from Thales similar triangles, are used most powerfully to create a z parameter or perspective scale in Flash 9 Papervision 2. Now, this is all incorporated in the Flash player, Flash 10, but let me tell you, they're still using these same equations. It's perspective scaling, and you've seen the derivation here. In the next video, we'll go along and use this to create an animation engine.